Our March 2016 Discovery Series presentation live streaming for the second time from our home studios at CFRI in Palo Alto, California. We're very pleased to have you here. I am Sue Landgraf, Executive Director of Cystic Fibrosis Research Incorporated, CFRI as we are fondly referred to. And I am very pleased to welcome all of you here in the studio tonight, as well as our online guests. We have a very special program for you tonight, but before getting started, I would like to thank our sponsors, Vertex Pharmaceuticals, Genentech, and Chiesa USA for generously sponsoring tonight's event, and we have additional support from Novartis, so we appreciate their support, or we would not be able to bring this wonderful program to you tonight. I know I share this with you every time, but it's very important to remember. We urge you to work together with your healthcare team, and no information presented here tonight is supposed to be for a patient's diagnosis or treatment, so please work carefully with your healthcare team. Thank you. And as usual, a big round of applause to our CFRI Live team. We have Mary Convento, Scott Wakefield, Siri Vaith Dunn, and David Suhu with us here tonight. And so thank you for making this possible. This is happening in real time, and at the end of tonight's presentation, I encourage every one of you to ask questions, whether you're here in the audience or online. For those of you watching online, please click in the chat box on your screen and type in your questions. Mary will ask them on your behalf at the end of the presentation. So please, please don't be shy. This is a wonderful opportunity for you to ask questions of a very renowned CF researcher. So we might as well get started. While cystic fibrosis is a multi-systemic disease, progressive lung damage caused by opportunistic infections remains the primary cause of respiratory failure. The treatment of infection is key, but there are many, many theories about the optimal strategy for doing so. We are very fortunate to have with us Jeffrey Wine, PhD, who will present Youngsters with Cystic Fibrosis, an argument for treating while healthy. Dr. Wine is a professor of psychology, human biology, and pediatrics at Stanford. That is very impressive. And he is also the director of the Cystic Fibrosis Research Laboratory over at Stanford University. Dr. Jeff Wine is renowned in the field. Thanks to his pivotal work, our understanding of cystic fibrosis has been advanced significantly. Dr. Wine's knowledge of CF extends beyond professional to the personal. He has a daughter, an adult daughter with cystic fibrosis. And I must add that CFRI is proud to have helped fund Dr. Wine's research through the years. So please help me welcome Dr. Jeffrey Wine. Come on up, Jeff. Thank you.
Thank you, Sue, for that wonderful introduction. And thanks, CFRI, for you folks here are doing above and beyond the call of duty, late at night working. And I also like to thank those of you who have tuned in or who might watch this later, because it's always been my view that when parents are engaged, children do better. Now, I want to say at the beginning that I always feel a bit nervous about giving this talk. And the reason is that my focus is going to be on young children before they have shown the ravages of cystic fibrosis and what you can best do then. But as we know, most of the people in our community, the people that we work with, the people who are out there raising money, have children who are older and sometimes more severely affected. And so this is difficult, and I hope you'll just understand that we do the best we can. What I'm going to say tonight is quite controversial, but the general notion of this title, I think, can't possibly be controversial for much longer. Ivacaftor, or Kalydeco, and Orkambi, almost everyone who's thought about it thinks that those should be given to children as soon as it's possible. So before the children develop all of the problems with cystic fibrosis, they should be taking something that corrects the basic defect. But I won't be talking about that tonight. I'll be talking about what to do for those people who can't yet take those drugs. Okay, so some disclosures. I'm not an MD, so if you say, what particular variety of drug should I use, I won't know. I am a scientist devoted to CF research, I'm trained in electrophysiology and neuroscience, but now I do epithelial biology and study the innate defenses of the airways. I have no conflicts of interest. And as Sue mentioned, this talk is based on CF research findings, but also on my experience as a parent of a daughter with CF. So this is the objective of the talk. You want to keep your CF child as healthy as possible. You need to understand that lung infections are the major problems in CF, and I think now almost everybody does. We need to consider the possibility that current standard of care is not optimal. If you think it is optimal, then why would we be doing research to make it better? So it has to be non-optimal. And third, as I said right at the beginning, to realize the importance of deep involvement in your child's health and the need for constant vigilance. And at this point, I think it's fair for me to say, because I'm going to be doing a lot of bragging about the health of our daughter, but the real effort, the real genius of keeping her healthy falls mainly on two people, on her mother, who's with us tonight, and on her herself. So when she was younger, the mom did it. When she was older, she took over her own care. We like to say in our house that I take care of all the major decisions, like what should our policy be relative to the Iraq War. And Marlene deals with the day-to-day things like keeping the children healthy. So the basic message today is don't delay. And there are many sayings that say the same thing, a stitch in time saves 9, and so on. But of course, there are also sayings that make the opposite point, like fools go in where angels fear to tread. So you get both kinds of advice. And so a deep message in all of the work that I do and that I will convey to you is that you can't take what I say without really deeply thinking about it yourselves. Each and every one of us has to try to be our own expert as best we can. Let me tell you, if this is good advice, let me give you some bad advice. Bad advice is, if it's not broke, don't fix it. Well, people with CF are born with broken CFTR. It's always broken, and it can't yet be fully repaired, although we're working on it. So the goal is to minimize the damage caused by that broken CFTR. And as Sue mentioned, the most critical organ to protect is the lungs. So is it possible for someone with cystic fibrosis who's not being treated with some of the new fantastic drugs to stay healthy? So I want to start off on a high note. It is possible. So this shows our daughter, and she's running in one of the many events that she runs in. She ran in the LA Marathon, the Barcelona Marathon. She's been in multiple triathlons and sprint triathlons, and she's now training, and I'm a little worried about this, a 70.3 mile Ironman, half Ironman it's called. And that, you can see what it involves. And I mean, I would be hard pressed to do this in my car. And so it's quite impressive that she's able to do this. And of course, the reason I'm telling you this is because she has cystic fibrosis, and she doesn't have some mild version of cystic fibrosis. She's 35 now. She has severe mutations. She's been pancreatic insufficient since birth. She has a very high sweat chloride level. She's had chronic aspergillus, which is interesting, throughout her life. It hasn't seemed to bother her. And when we test her with this sweat test that we have developed to detect small amounts of CFTR function, she has zero function by that test. So she has severe CF. So you can't point to her and say, well, somehow she's a special case. But she is a special case, but it's what's been special has been the environment. So let me show you 5 assertions that I'm going to make in the talk. These are, well, you can read them yourselves while I take a drink. So let me go to the very last one, chronic infections. And I think you heard a talk a couple lectures back from Dr. Elizabeth Foley about chronic Pseudomonas infections. Chronic infections with Pseudomonas or anything else can be prevented with available treatments, and healthy lungs tell us how. So that's one of the assertions, and I want to give you some evidence for that. Now, this next slide is the longest slide, the most complicated slide I'll show you, but it kind of says everything all at once. So what this slide is showing you is that this is her condition, and this long string of boxes indicates her life up to now, as defined by bacterial cultures. So every time you see a white oblong box, that means that the bacterial culture was clean. And when you see a colored one, it means she had one of the bacterial infections shown here, Pseudomonas, a Chromobacter, or Stenotrophomonas. Now, underneath this timeline, you can see the treatments that were used for her. She started off with inhaled antibiotics, which she took automatically whenever she showed any kind of sniffles. And this was, again, Marlene doing this religiously. One of the things, like all parents with all children, you get into arguments, I'm not going to do this, I'm not going to do that. This was non-negotiable, okay? You take the treatment, you do the treatment. 2 weeks, little sniffle, bang, on comes the mask. She would try to hide her little sniffles for that reason. So she was treated with this miracle drug, a mixture of amikacin, polymyxin B, isoproterenol, and bicarbonate. Where did that come from? How did I find out about this mix? Well, first of all, this was devised by a brilliant MD at Stanford, Bert Harvey, so it was called Harvey's Mix. But Nina's pediatricians, neither one of them, Bert Harvey wasn't her pediatrician at the time, mentioned this at all as a possibility. So how did I find out about it? Well, one piece of advice I could give you, and since people in the CF community around here are very fortunate, because there are many of us, if you're farther away, then you have to dial in for events like this. I found out about it because I went to an event that was organized by CFRI, and there were all of these people at a hardware store, and they were selling hardware, trying to raise money for CFRI, and everybody could be there, including a lot of CF patients, so there were a lot of CF adults there. And I did something that seems, in retrospect, brilliant. At the time, you might say, well, What I did was I looked around and picked out the healthiest, oldest CF person there and said, how do you take care of yourself? And he told me about Harvey's Mix. Okay. That was Bob Stewart, for those of you who remember the Stewarts. So you see that this stops right here, and that's because at that point, the pharmacy would no longer make Harvey's Mix. They said, you're the only person who ever asks for it, and we can't keep doing this for one person. But fortunately, just about that time, Toby was improved, and so we started inhaled antibiotics and high and hypertonic saline pretty much daily. Now, the problem is, you can see, is that you started to get a lot of infections during this period, but look at the age here. So this is a time when Nina was showing her independence, leaving home. Marlene couldn't nail her feet to the floor, and we think that that accounts for a lot of this. There were some serious problems there. In a few cases, she had to have IV antibiotics, but primarily we relied on inhaled. And notice this hospitalization that occurred when she was 6 months, right after she had been diagnosed with CF. That's the only hospitalization she's had in her life. And I think that's a good evidence that what I'm going to tell you about is probably a kind of treatment regimen you might want to consider. So she had Pseudomonas on and off, and these are called, if you watch the other lecture, these are called acute infections, and they were eradicated, they come back, they're eradicated, they come back. I once had a CF doctor say to me, not any of the ones that we know and love, say to me, why do you work so hard to eradicate Pseudomonas? It's just going to come back again. Well, we now know that it's critically important to eradicate it, and yes, it will come back, and then you eradicate it again. And maybe you can prevent it. What happened at this point is she couldn't get far enough away from home, so she moved to Barcelona, Spain. And shortly after moving there, she had this bout with Achromobacter. Now, the Achromobacter is something like a Pseudomonas, except instead of having one cilia, it has a whole bunch, and it's not susceptible to tobramycin. And so we kept hitting her with all kinds of antibiotics. And she would clear, but it would come right back, and clear. This one is a clear culture, and then come right back, and clear culture, but then come right back. Now, when you have so many positive cultures so close together, it really meets the definition, most people's definition, for a chronic infection. And most people at that point would have switched to a chronic regimen. And we were really beside ourselves. We just didn't know what to do. By the way, she was doing quite well, running, exercising, doing quite well. And in retrospect, what we now are pretty sure is that the levels of bacteria were very, very low because she has not sustained significant lung damage during this period. So how did we get rid of it? Well, another mother, this is a mother that we met online, who first saw me through one of these programs and followed our advice for her child. Then she had advice for me. She said, we were just in Denmark and we were talking to Niels Høiby and Pressler about their protocol for getting rid of Achromobacter. Have you tried that? Of course not, I said. Nobody had suggested that. So we tried that, and it eradicated it after a long time. It took a long time, but now she's been clean since. So the lesson here is never give up. Don't assume that it's a chronic infection don't assume it ever, is what I would say. Okay, so the lessons here are that prevention works, but not perfectly. Eradication works, never give up. Okay, that was a very long time on one slide, and I'll go quickly now. You've heard this point before, some of you. Cystic fibrosis, in my opinion, is two really different diseases. One marked by acute infections where there's really little change in the person, and one where the person is chronically infected, and then you get decline in lung function of variable rate. And so, obviously, you want to stay in this category. Dr. Foley, in her talk about Pseudomonas, said it's really important to know your enemy. And this is what Pseudomonas does to the lungs. This is a lung that was taken out at transplant from a young woman who was only 14. So that's what happens when it doesn't go well. So what is it about CF airway infections that makes them so terrible? I'm going to run through this with you because this not only, I'm not just saying what is it that makes them so bad, but it also is clues and explanations of how they can be fought. The first thing is not controversial. People with CF die from chronic lung infections almost always, not always, The man I mentioned earlier died actually from a liver problem. And they're bacterial, not viral. But viral infections often lead to bacterial infections. So viral infections are important. But the next point is really, really, really interesting. Bacteria are found in mucus. They're not on the airway surface. They're found in the mucus exclusively that coats the airway surface. Why is this so important? Everybody at CFRI knows the answer to this question because I keep harping on it. It's important because, well, first let me prove to you that it's true. Bacteria are entirely in the mucus. So this is a micrograph taken from investigators in Germany and University of North Carolina. This is the mucus. This is the airway surface. This is a shrinkage artifact that caused the mucus to go away. So the mucus would normally be right on the surface. And these are the bacteria. These are called little microcolonies, okay, or macrocolonies. And so if this mucus left, there would be no bugs in the airway. And this just shows a close-up of one of those, and this shows how far away the bugs are from the surface. Most of them are more than 5 microns away. That's about 5 bug lengths away. 5. So if this is true, then what happens is that if you clear the mucus, you clear the infection. Let me say it again with clear the mucus, clear the infection. That's my only little jazzy thing that I'm going to do tonight. So, because it's really important. There's another really interesting thing about these infections. They are heterogeneous. They start high and they move low. Why is that important? It's important for several reasons. First of all, infections in nasal passages can get into the airways. So you can't take nasal infections for granted. And remember, this talk is focused on parents of really young children. And so if you go in and they do a sputum culture and you don't have any Pseudomonas, you might always want to ask, could you check the nasal passages? Is there anything going on there? A lot of work has been done in Germany, in Belgium, showing that it's critical to find out what's growing up in the nasal passages and to do something about it. One of the things that we always did was with inhalation therapy, made sure that a significant portion of it went through the nose as well as directly into the lungs. So I could say a lot more about that, but I'm going to move on and talk about this one. This was also mentioned in the last talk. Pseudomonas evolves if not eradicated from the lung. So that's a really interesting notion. We usually think of evolution as something that, led us from being apes to what we are now and got rid of the dinosaurs. But Pseudomonas, because they grow so quickly and divide so fast, evolve so amazingly fast that it's frightening. And why are they evolving? Well, let's take a look. Everybody's going to get, if you have cystic fibrosis, you're going to get an infection with something. It's just absolutely the case because the innate defense mechanisms of the airways are broken. So you get an acute infection, and so you get a lot of these bugs in the lungs. But because of selection, the same kind of selection that causes a giraffe to have a long neck, because of that, you end up with a different kind of bug living in the lung. A bunch of bugs that have learned to live, have evolved to live in the cystic fibrosis lung and avoid the ways that we use to get them out, including antibiotics. So that's called a chronic infection if you let it go long enough. And let's look at a particular case that's been studied in detail. So this is an 8-year-old girl. And what they did was go back and they had collected cultures from her over her lifetime. And they took those cultures and they looked at the Pseudomonas with modern molecular biological methods. And each one of these little balls represents a new mutation. And a green one shows a persistent mutation. So by the time she is 8 years old, she's collected 68 her Pseudomonas has 68 separate mutations in it that have helped it to adjust and stay in the airways. This by itself explains why it's so important to keep eradicating, so that then you get another infection, but it's a wild type guy. So you keep knocking them out and you don't let them go down this pathway. That's crucially important. Somebody asked at Dr. Foley's talk, what about the mucoid? How long does it take before things go to the mucoid form? Well, there's good news and there's bad news. Two kinds of bad news. One, the mucoid form is very bad. And two, the way that most CF patients are being treated guarantees that they're going to end up with mucoid Pseudomonas eventually. The third piece of bad news is that, this is non-mucoid, this is mucoid. It's important to prevent mucoid Pseudomonas because the mucoid form is much more resistant to be declared. To the best of my knowledge, no successful eradication of mucoid PA. But here's the good news. It's both good and bad news. It's good news in that it takes a long time for this to happen. It's bad news that, nevertheless, people let it happen. So here's the news. This is a study, and what you're looking at here is the age of children in a clinic, and this is the percent of the children of each age who are free of infection. These are the proportion of children who have pseudo-aeruginosa infection, but a non-mucoid variety, and this is the percent who have a mucoid variety. So by age 16, virtually all of them have converted to a mucoid form. But how long did it take? The transition time from non-mucoid to mucoid was relatively long, almost 11 years. So there was plenty of time to get rid of this thing before this happened. There was a hint that this could be slightly extended by brief, low P. aeruginosa antibiotic treatment. Well, there's a real hint. If brief and low slightly extend it, maybe high and long will extend it a lot longer. It seems to. I mean, I'm not a MD, but that seems reasonable. So when was this done? Is this ancient history? Well, this was done from 1985 to 2004. This study. So let's compare that with this thing that we saw before. That's this period during here. So had she been at the clinic that we just talked about, she would have had about a 98% chance of having a chronic mucoid Pseudomonas infection somewhere about here. Okay, so the last point is a really critical one too. Infection and inflammation causes bronchiectasis. I'm going to tell you what bronchiectasis is in just in case you don't know, but here's why it's so important. Why is this important? Well, bronchiectasis is when the smooth, hard tubes of your airways start to melt, and they bulge out, and they form little pockets where pus can collect, and so you cough, and instead of it getting whooshed out through this rigid tube, it just bulges up and stays in there. So the airways are floppy, they dilate, it's really bad. So chronic infections cause bronchiectasis because the chronic infection brings in all the neutrophils and they actually dissolve the cartilage. And so this is a terrible thing. You don't want this to happen. And to show you how bad it is that this happens, there is actually an experiment of nature in which a perfectly healthy airway had the cartilage taken away first. And that's something called Williams-Campbell syndrome. And people with this have a congenital bronchial cartilage deficiency. This is showing the trachea, but it's down here in the bronchi where the cartilage doesn't form well. And so they're born basically with a bronchiectic-like condition. And what happens? They get recurrent infections. So this means that we've got a vicious cycle here where infection causes tissue destruction, more infection, bronchiectasis, which leads to more infection. So you go round and round and round, and that's not good. How do you stop this? Well, the best way is by using newly available drugs. If they work for you, those will hit the basic defect, which is the fundamental. That's what we want to do. That's the way we're going to deal with CF. But until you have that drug in your hand, and it's coming, but not here yet, completely for everybody, the next thing you can do while you're waiting is to minimize infections, okay? How can we do that? How is it that healthy airways avoid chronic infections? All of us here breathe in tons of bacteria every day. When you eat a salad, you don't want to know how many Pseudomonas bacteria you're breathing in. And that's even a nicely washed salad. So, but you never get bacterial infections, very rare. Almost the only way you get a bacterial infection is if you first get a really, really bad cold. That predisposes you to a bacterial infection. That's why doctors don't want to give you antibiotics for colds, because typically you don't yet have a bacterial infection, and most of us won't ever get one. How does that happen? Well, the normal airway, I won't go through this in great detail, but the normal airway has CFTR present in the surface and in glands in critical regions where it contributes to the production of an antimicrobial, bicarbonate-rich, nice, smoothly flowing mucus that flushes these things out and cripples them on their way out. So they don't have a chance. They land in this stuff, and most of them are killed immediately. That's been shown with the work with the CF pig at the University of Iowa. Most of them are killed right away, and then out they go. But in cystic fibrosis, of course, CFTR is gone, both in the glands, in the surface epithelia, and so this mucus doesn't move as fast. The antimicrobials in it don't work as well. A new evidence suggests that's because there's unopposed acid secretion. Normally CFTR is helping to secrete some bicarbonate. And so you get this life-threatening buildup, unless you act to get rid of this. Okay. Let me just point out one thing about this elixir of airway health. One of the things I'm going to tell you is that you need to use a lot of antibiotics, and that's what your bodies do. So this was, Manamsu works in my lab, and he collects little bubbles of mucus from human airways that have been removed either as donors that haven't been used or as little tracheal pieces that haven't been used. And if you look at the mucus from these little glands, you find that the mucus is chock full of proteins. And when you analyze those proteins, you find that huge numbers of them, at least 102 in this small sample that we did, 102 different kinds of proteins are acting in an antimicrobial fashion. That explains why the bugs that we breathe in don't become immune, don't adapt and become able to live in our airways. There's too many bugs for them, too many antibiotics working against them. Okay, so we went through these 4 points. You want to eradicate. You want to prevent. Let's look at this one. Chronic infections can be prevented by optimal use of available treatments. Healthy lungs, as I just indicated, tell us how. Let's look more closely. How do we optimize existing treatments to prevent chronic CF lung infections? I'm not talking about miracle drugs. They're on their way. I'm just saying what we have available now. Well, the first thing is to optimize mucus clearance. Why is that so important? We all know now why that's so important. It's because the bugs are in the mucus. So if the bacteria are in the mucus, then mucus clearance is really important. And that's why these guys pointed out long ago, this is Mike Knowles and Rick Boucher from the University of North Carolina. They pointed out that mucus clearance is a primary innate defense mechanism for mammalian airways. So clearance is the thing that you want to do if you have CF. The best way to do that is with exercise, but if for some reason exercise isn't possible, either because of illness or because you've got a little infant, the vest can work. Hypertonic saline, pulmazine. Notice that I have ands here. MDs are often looking for what's the best single treatment we can use, because legitimately they want to reduce the treatment burden on subjects, on patients, and on their parents. But these really do work better together than they do individually. Start early, before infections. Prevention is important. Why is that so important? Okay, this is the most controversial thing probably in the field of cystic fibrosis. Preventing infections before they occur with prophylactic treatment is so controversial because antibiotic resistance is known to be an extremely important problem, and therefore there's resistance to use antibiotics. But the problem is, I see where some of the content's missing. But you need, this is, okay. So when we started the computer, something got lost, and this next slide was the most important slide. It gives the key elements of how you can do all of this. So, sorry. I actually don't know what's on that slide. Let me think. Nope, lost the notes too. Okay, so we have to jump ahead to using multibiotics simultaneously. Let's see. Oh yeah, okay, I can fill in what's going on here. The reason that you want to start early, before infections take hold, is that you want to hit the bacteria when there are very small numbers of them. The reason for that is what I'm now going to talk about. So, too bad that slide's missing, but use multiple antibiotics simultaneously gets at the same, some of the same points. So what I showed on the slide that didn't appear, and it's really a shame that it didn't, because I don't want to get hung up on that. It just shows that, let's see if I can reconstruct this. What it shows is that the way bacteria multiply, they multiply in a dish about every 20 minutes. And they multiply in the lungs less frequently, but enough so that you will go from 1 to 1,000,000 times as many bacteria in just a matter of a small number of days. So after about 30 days in the lung, you have an enormous number of bacteria. And what the slide shows was this big increase in the number of bacteria. And the bottom line, the message that slide, maybe somebody tried to, anyway, the bottom line of that slide was, if you really want to treat infections only when you know there are bacteria there, you better be getting cultures at a minimum of 30-day intervals, and probably every 2 weeks, and nobody does that. And that's why giving the antibiotic prophylactically sometimes is what we decided. There was no other way to do it. We just couldn't have that many cultures. And if you have any fewer, you're going to be dealing with a lot of bacteria. And why is that important? And why do you want to use multiple antibiotics? So bacteria evolve resistance in multiple ways. Here's just 4 different ways. It doesn't matter. It's just what's important is they're different ways. So they have different strategies. This next thing you need to know is that mutations occur about 1 in 10 to the 8 replications. So if you have, this is what the other slide shows. In 1 teaspoon of CF sputum, you have between 5 times 10 to the 8 or 5 times 10 to the 10 bacteria. That's a lot, right? So this is 500 million, and this is 50 billion bacteria in a teaspoon. That's more people than there are on the surface of the earth. So if you wait until you have this many bacteria, then the probability that some of them will have mutations becomes really high. Suppose 1 in 100 million are resistant to an antibiotic that you use. Well, then it's almost certain if you have more than 10 to the 8, which you're going to have 5 times more in the lowest estimate, then you're going to automatically get antibiotic-resistant bugs. So I wish this slide had been dropped because this is the most complicated one. The point is that when you use antibiotics simultaneously, the probability that a bacterium could be resistant to both is the product of the two independent probabilities. And since these are such big numbers, the probability quickly comes from a reasonable number to one in which you're just not ever going to encounter a resistant bug. So this all works even better if the starting population is small, and that means starting early. So use multiple antibiotics early before the bacteria have proliferated into these huge numbers to preempt infections, and use multiple ones so that if is a resistant bacteria there, you can get rid of it. Okay, I'm running over here. That's too bad. So who uses this effective strategy? Well, that's why HIV/AIDS is not killing everybody these days. They now use at least 3 drugs to deal with HIV/AIDS after so many thousands of people, millions maybe, of people died using single drugs, which they became immune to. What else? Tuberculosis. At least a combination of at least 4 drugs is now needed to treat resistant tuberculosis. But there's an even closer example that we all know, and I gave it to you earlier. This is what your own lungs do. This is why your own lungs use multiple antibiotics. So what antibiotics should you use given this? Okay, I'm going to go through this very fast because we're running out of time. This shows that a normal cell has 6 places where it's quite vulnerable to antibiotics: the production of DNA and RNA and protein, and then the construction of the cell membrane and the cell wall. And each and every one of these steps has a class of antibiotics that are designed to interfere with it. And within this class of antibiotics there are interesting individual differences between the antibiotics. Now, as a parent, you can't possibly make sense of this. All you can know is, all I'm proposing is that when you talk to your doctor, you say, I don't want 1. I want 3. You can pick which 3, but just pick them according to this kind of basic fundamental information. Pick them by first looking to see which antibiotics the bugs are resistant to, if they have bugs, and then using a couple like that. All right, that makes perfect sense to me. Now, notice that I'm indicating with big red and blue letters which ones are now available or will be available for inhalation. Why is inhalation so important? Well, you always want to use inhaled antibiotics, if at all possible, for cystic fibrosis lung disease, for a very obvious reason. If you take them orally or you take them IV, then they go everywhere in the body, and only few of them get into the airway lumen. Whereas if you put them directly into the airway lumen, you can put concentrations 1,000 times greater than you can with either of the other methods, and they don't bother all of the other organs that you're worried about. So, this is a summary of the strategy. Bacteria grow exponentially very fast, and then they reach a stationary phase. In a dish, they decline. In the lungs, they just stay here. okay? What happens in the typical cystic fibrosis clinic is that people are not recognized until they have enough bacteria in the airways that they're sick, and then they come in to get treated, and then they suppress. Or maybe they eradicate it the first time, but we heard in the prior lecture that eradication that usually only works a few times, and then you're in a chronic situation. So suppression is typically what you're getting in most cystic fibrosis clinics in this country. But if you're a CF patient or a parent of a CF patient, you want eradication every time. Okay, to summarize, our airways keep themselves basically sterile by a combination of mechanisms that depend heavily on CFTR. In cystic fibrosis, CFTR is gone, and so it's life-threatening, and you get this buildup of mucus and all of the other bad effects that we saw. So I want you to think about inhaling antibiotics in a different way. When you think about it, I only take antibiotics, I only give antibiotics to my child when the child is really coughing up thick mucus. Instead of thinking that way, remember that what you're trying to do, you're trying to restore this situation. And so what you should do, I think, is consider inhaling antibiotics and increasing mucus clearance with these exogenous ways is exactly analogous to taking pancreatic enzymes. You don't wait until somebody has a crisis before you give them pancreatic enzymes. If someone's diabetic, you don't say, oh, we want to minimize your use of insulin. You don't say those things. Now, of course, those situations are not exactly the same because there is an issue of antibiotic resistance. My whole point, I hope it came through here, is that the way to avoid antibiotic resistance is what I'm suggesting. And the way to produce antibiotic resistance is dribble in antibiotics after you've got 10 to the 8 bacteria with mutations. Dribble them in one at a time. So CF is 2 diseases with a one-way transition. It's very hard and maybe impossible to go back this way. But this transition is not inevitable. You can prevent it with a lot of hard work. And once again, it's easy for me to say, but the person who did most of the work is in the audience. And so just to conclude on a high note, this shows what happens with one person who is treated in this way and is still treated in this way. She's quite healthy. And it's not just that she's gone past the median survival. It's that she's living a full, healthy, productive, dangerous life. All right. Thank you very much.
And Jeff, if you'll stay up there, I'm sure we have some questions.
All right. Thank you.
I'm going to kick it off. And full disclosure, not only do I work at CFRI, I am the parent of a daughter with CF. So I have a slew of questions, but starting from the top, your thing about it starts at the top and works its way down. I always marvel, my daughter has terrible sinus disease, but I don't know that her sinuses have ever been cultured. So what is the disconnect there? She goes to the ENT, it's all part of her CF care. She's had multiple sinus surgeries. Why isn't that? What's your theory that they don't connect those dots?
So sinus infections are interesting in the sense that they are fairly walled off. So that's why they're so hard to get rid of. But also it's why they don't disseminate quite as easily. So infections in the other parts of the nasal passages, I think, are more dangerous. So you have an expert who comes to CFRI, Peter Huang, who knows all about the sinuses. And so he's the one that we see. This young lady has never had any sinus surgery either. But we came this close to it twice. And it's a long story about why we didn't go through with it, but we went in, we had case conferences, all kinds of things, and in the end it was decided not to do it. The thing about sinus surgery unlike a lot of other things in CF treatment, it's irrevocable, right? You can't undo it. So you want to be really sure before you go ahead and do it. And when we went around the country and talked to everybody we could find to talk to who were expert in this adder, we got really very different opinions. So it was standard of care for lung transplants at Stanford for a long time. If you wanted a lung transplant, you had to have sinus surgery. I don't know if that's still the case. It'd be interesting to know. I'm not sure I answered your question.
It just seems there is a disconnect, and I'm just wondering, I mean, is this something that parents should think about advocating for? I'm just thinking how easy that would be to collect a culture.
It's not easy. It's not easy to get a sinus culture. Easy to get a nasal culture. So I'm suggesting more the nasal passages more than so there are different sinuses, but the big ones are the maxillary sinuses under here, and they have a little tiny opening into them, and then they're about the size of a walnut. And the way you can tell if there's a problem, well, that's not true either. Everybody with CF, almost everybody with CF, has a pacified sinuses. That means they get filled up with gunk, but you don't know what that gunk is. It could be clean, it could be filled with Pseudomonas. Usually, if it's filled with an infected material, there's other signs. There's headache, there's all kind of other issues. But again, Dr. Huang would be the person to talk to about that.
I'm sure we have questions from our online audience, but if I could just ask one more before I pass this along, and it is geared towards for younger families. It does that question of eradication and not accepting colonization and always pushing, and I guess your tips for families who are newer to the CF journey and really learning how to advocate for themselves and for their children to stand their ground to push for eradication.
Yes, that's exactly right. And there'll be a lot of pushback, and depending on which particular person you're seeing, which particular clinic you're in. So yeah, probably should have a whole nother session on advocacy issues, but it's true, and and one of the reasons I gave the talk is that we're all, I'm certainly in this way, we're in a position where we know less than they do, typically, and one of the things that the most common pushback that you get is they'll say, there's no evidence that what you're proposing works. And that's true, because I've never done the studies. Okay? I consider what we just saw as evidence that it can work, but it's an N of 1, and scientists don't like N's of 1 for very, very good reasons. So what a parent has to do then, unfortunately, what we have to do now, what we had to do for 35 years is read the literature, talk to as many people as we could, and try to make the best determination, and then arm wrestle to get what we could get done. And it doesn't always work. For example, the treatment that I showed you, the Danish protocol that finally cleared the Achromobacter was absolutely refused in this country. There was no way. They said, you're not getting this treatment. Your daughter is too healthy for this treatment. It was only when she went back to Europe that she was able to get it. So it doesn't always work.
Okay, I actually had a similar question that Siri asked online, but specifically they're asking if the doctor says no, what would be the next step for them to take?
I'm sorry.
Oh,
I'm not sure.
If a patient or actually a parent with a newly diagnosed patient goes in and suggests and wants to take a combination of antibiotics, and the doctor says no, what actions could they take?
Well, I guess what we used to do is we would say, why? What's the argument against that? And then try to remember this argument in favor of it. Unfortunately, that one slide, that was for early treatment, is not there. go online and look for, there's a number of places in Europe. There's especially a clinic in Belgium that has a spectacular record now. Also, Hoebe and Presser's clinic in Denmark have a really good record. And the other thing is, if you look at what's happening now in the CF meetings, they're starting to talk about this, and they're starting to advocate trials with a couple antibiotics. And so eventually they'll get to this point, but eventually it's a long time if you have CF.
Okay. I have another question. You talked about a little bit about prevention. I have an energetic 5-year-old. So there are new infection control standards. Everyone's having to stay in the room for 14 days without going out. He's allowed 3 days a week to walk to the hall, but the PT, I don't understand how her question goes. But basically, she's wondering, is this really the best? What's your feedback with respect to the patient's quality of life in cross-infection control at the hospital?
You're not going to like this answer, but the answer is try not to go to the hospital, right? You try to keep your child out of the hospital at all costs. That's really the best answer. I know it's not always possible. Once in the hospital, though, I think I would agree with the infection control policies that are now present there. You're not in the, hopefully, you're not in the hospital that long. And so quality of life, to me, the best quality of life is when you're healthy. So one of the arguments, one of the pushbacks is, well, this is really hard. This takes a lot of time. Yeah, it does. But I'd rather have that and be healthy than say, okay, I'm not going to do a 40-minute treatment every day, but end up in the hospital a couple times a year. So yeah, try to stay out of the hospital is the advice I would give. I think that's true for everybody, by the way, not just people with CF.
Hi. I really liked your talk.
Thank you.
I had a question in regards to your daughter, and was she doing the vest when she was working out all the time?
So
or did
she never did the vest. She I think, can you remember the story? She hated it. She just did. I loved it. I wanted it just for relaxation, right? There's nothing wrong with my lungs, right? I thought it was great. I couldn't understand why she hated it, but she hated it. And I'm just speculating. We should have talked about this more. She was quite young at the time. I think she saw it with all the things. She just saw it as somehow I think she felt a stigma associated with it, even though it would have been the privacy of her own home. Okay. So fortunately, she loved to exercise, and I think exercise is by far the best if the person can do it.
And mainly just running, or was she doing other aerobic?
She mostly ran early on. It's only later on that she started this. It was only later on that she started this triathlons. And I don't know if they have.
I can't hear anything.
By the way, so again, every case is different. Every time she went swimming, she got an infection.
Oh, the picture's frozen too.
Never let her just swim, but I know a lot of CF kids who swim a lot and don't have this problem. So it's probably individualistic. I don't know why she was so susceptible.
Do you have time for one? There's time for one more. The word with Pseudomonas always is, it's ubiquitous. It's everywhere. And yet that word is not used as much with staph, which also is. And so I'm just curious, because quite often my brain is, when you're talking about using multiple antibiotics, I'm thinking about Pseudomonas and Ascaltophilia and these other bacteria, but staph, or would you advocate for, especially for kids whose lungs are still relatively clear, eradication for staph, eradication for any bacteria that you're culturing?
Well, I do. It's interesting, there was an early history in which people thought staph was less of a problem. I don't understand one of the many mysteries, and one of the reasons that, one of the mysteries I don't think people can really explain is why some children with CF get staph right away and others don't. My daughter never had staph, that we know. Now, one possibility is it turns out a very large fraction of people, normal people, have staph in their noses just naturally. So I think there's literature out there. I just am not up on it. I'm really weak on this in the staph area. You guys ought to get a staph expert in here to talk about it. That'd be a really good thing to do.
Give me all sorts of topics for future Discovery Series.
Yeah, no, that'd be great.
Some questions?
That's it. Thank you. Let me just do this. Yes. Sorry. All right, I'm out of here.
Yeah, but you can't leave because I have another question from somebody else who called in. So Sue apologizes. She had to scoot out the door. So Jeff, thank you so much for your incredible presentation, and we're just so honored to have you as part of our CFRI research community and part of the whole larger CF family. And I want to thank everybody here for joining us, and to those of you watching online, thank you for joining us from near and far. Once again, thanks to Vertex, to Genentech, to Chiesi USA, we don't have a representative here, and also to Novartis for your incredible support of CFRI and specifically of this program here tonight. From all of you who are watching, we look forward to seeing you at our next CF Discovery Series, which will be on April 12th, Tuesday, April 12th. And before we leave, Sue and I were discussing that we have this wonderful opportunity to reach everybody who's watching, and we should use this to close out to encourage everybody to go to our website and take advantage of all these programs that we're launching here in 2016. And really with the support of the companies that are here in the room, we are launching our MBSR class, Mindfulness-Based Stress Reduction class. It starts on March 31st for people with CF who are 16 years old and above. And last year, the results from that program were just phenomenal in decreasing depression and anxiety amongst those with CF. We have a caregiver support group every month. We have a retreat next month for mothers of children with CF. We're planning for our large conference this summer. We have an incredible lineup of speakers this summer, and we have many other programs, so please go to our website. And finally, in closing, you can see this gorgeous graphic. It's time for a cure. Mother's Day Tea is CFRI's largest fundraiser. This is where the masses come out, and it's all those donations that collectively create huge support for this organization. So I just want to put a plug to people. If you're not a tea sender, please consider it this year. We have these lovely invitations. We give you everything you need. It's very easy, and it not only broadens financial support for CFRI and our programs, it also helps to raise really vital awareness of CF. So I put that out to the world. Please contact us at the office and we will take care of you. So thank you again for joining us tonight, and we look forward to seeing you next month. Thank you.